Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. In this video, we are going to cover chapter 2, data model. In this chapter, you will learn about data modeling and why data models are important, right? And then you learn about the basic data modeling building blocks, okay? And what business rules are and how they influence database design, okay? Next is how the major data models evolve and how data models can be classified by level of abstraction, right? Okay, you have learned about database design in chapter 1, right? So database design focus on how the database structure will be used to store and manage end user data, right? So data modeling is the first step in designing a database, which is refers to the process of creating a specific data model. Okay, what is data models? Data model is a relatively simple representation, which is usually graphical, okay, of more complex real-world data structures. Okay, in simple terms, a model is an abstraction of a more complex real-world object or event. Okay, what is the importance of data model? Data model basically can facilitate interaction among the designer, okay, the applications programmer, and the end user. Um, it plays the role as a communication tools, right, that can improve understanding of the organization or for which the database design is developed. Okay, so normally end user have different views and understanding about data that they need. So we need a data models which can organize data for various users' perceptions in order to meet their requirements. Okay. Okay, these are the data model basic building blocks, which consist of entity, attributes, relationship, and constraint. Okay, entity can be anything about which data are to be collected and stored, and it represents a particular type of object in the real world. Okay, for example here, okay, it might be a person, place, thing, or event, right? Okay, next building block is attributes, which is referring to a characteristic of an entity, right? So, for example, we have a customer as an entity. So we can describe uh, the entity by attributes such as customer ID, customer address, customer name, customer phone number, right? Okay, next building block is relationships, which describes an association among entities. Okay, so for example, here we have a customer and suppliers as an entities. So a relationship exists, might be supplier supplies product to many customers, or each customer may be supplied by many suppliers. Right? So we have three types of relationships here, which is one to many, many to many, and one to one. Okay, data model relationship also can be described in both direction, and we call it bidirectional. This one. So for example, here we have a customer and invoice. Okay, this is typo, invoice. Okay, we have in bidirectionals, we can say one customer can generate many invoices, and the other way around, we can say each of the many invoices is generated by only one customer. Okay, so we can describe in both direction. Okay, so questions to identify the relationship type is basically how many instances of B are related to one instance of A. B and A is the entity, right? So the next question is how many instances of A are related to one instance of B, right? Okay, these are the examples of relationships. Please read and try to understand how to describe the relationship between two entities. Okay, for example here, painter paints painting. For one to many relationships, you can say that each painter may paint one or more painting, or each painting must be painted by one and only one painter. So it is based on the two questions in the previous slides, right? So please understand this slide, uh, referring to the questions given in the previous slides, right? Okay, now is the fourth building blocks, which is constraint. Okay, constraint is a restriction placed on the data, and it is important because it helps you to ensure data integrity. Okay, what is data integrity? Data integrity is the accuracy and consistency of data stored in database, right? So uh, constraint normally expressed in a form of rows. Okay, for example here, okay, a student GPA must be between 0 and 4. An employee salary must have values that are between 6,000 and 650,000. Uh, each class must have one and only one teacher. Okay, these are the rules example, right? Okay, now, how do you properly identify entities, attributes, relationship, and constraints? Okay, in order to identify those building blocks, okay, which is entity, attributes, relationship, and constraints, you must clearly identify the business rules. Okay, what is business rules? We discuss in the next slide. Okay, business rule is a brief, precise, and unambiguous descriptions of a policies, procedures, or principles within a specific organization. Okay, basically, when database designers go about selecting or determining the entities, attributes, and relationships that will be used to build a data model, okay, they might start by gaining an understanding of what types of data, how the data will be used, uh, in what time frames they are used, and so on and so forth. Okay, so the collection of data becomes meaningful only when it reflects properly defined business rules. Okay, uh, and business rules basically derived from a detailed descriptions of an organization's operations that help to create and enforce actions within that organization environment. Okay, so these are the examples of business rule. Basically, business rule must describe in simple language and easy to understand. Okay, if you look at this example, the first two example describe two entities, which is a customer and invoice, with one-to-many relationship between those entities, right? So the third one is the third business rule describe a constraint, okay, constraint, which is no fewer than 10 people and no more than 30 people, with two entities, which is employee and training, and the relationship between employee and training. So this is how we describe the entity, relationship, and constraint. Okay, basically the main sources of business rules are company managers, policymakers, uh, department managers, and it's from written documentations, for example, from procedure standard and operation manuals, and also can get from direct interviews with end users, which is this is the fastest way for direct source of business rules, right? Okay, business rules must be rendered in writing, must be kept up to date, must be easy to understand and widely disseminated, and can be described characteristic of data as viewed by the company. Okay, the importance of business rule is it can standardize the company's view of data, constitute communication tools between users and designers. It can allow designers to understand the nature, role, and scope of data, and allow designers to understand business processes, and also allow designer to develop appropriate relationship participation roles and constraints, and also can promote a creation of an accurate data model. Okay. Okay. Now, how to translate business rules into data model component? As I explained in the previous slide, right? Business rule is the proper identification of entities, attributes, relationships, and constraints. So nouns in a business rule will translate into an entity in the model. Okay, and verb will translate into a relationship among the entities. Okay. For example, the business rule, a customer may generate many invoices, contains two nouns, which is a customer and invoices, and a verb generate that associates the nouns, right? And the relationship here are bidirectional, which is a customer may generate one or more invoices, and an invoice is generated by one and only one customer, which is the relationship is one to many. Okay, this table shows the evolution of the major data models, right? This one. File system, hierarchical and network, relational, object-oriented, XML, and hybrid DBMS. Okay, basically you can read these tables for your information. Okay, the hierarchical model is the first model introduced after file system, which is developed in 1960s. Okay, to manage large amount of data for complex manufacturing projects, and the basic logical structure is represented in upside down tree. Okay, and it is depicts a set of one to many relationship between parents and its children segment. Okay, meaning that each parent um, can have many children, but each child has only one parent. Okay, basically you can read further in the textbook, page 35 and 30 until 38 for the hierarchical model. So I will skip the next slides and I will proceed to the next topic, which is the relational model. Okay, so please refer this figure in the textbook. All right, this one also. Okay, we have advantage and disadvantages of the hierarchical model. Okay, the model number 2 is the network model. Please read as well in the textbooks. Okay, refer this figure in the textbooks. Okay, the concept. Okay, now the relational data model. Okay, relational data model developed by Code in 1970 and considered ingenious but impractical in 1970. The concept is simple. Its computers lack power to implement the relational models. So today, microcomputers can run sophisticated relational database software. It is implemented through relational database management system. And the most important advantage is the ability to hide the complexity of the relational model from the user. Okay. Okay, a relation can be think as a table, and a table is a matrix consists of series of row or column intersection which is related to each other through sharing of a common attributes. Okay, row equal to tuple. Okay, this one we can look into the example in the next slide. Okay, relational diagram is a representation of relational database entities, attributes within those entities, and relationships between those entities. Okay, this is the example of a relational model in table forms. Okay, it shows that the tables, okay, these two tables, related to each other by sharing a common attributes, which is agent code. This one, right? So these two tables are related and linked through agent code, right? So, okay, this is another example of relational model uh, in a relational diagram, which is this diagram shows the relationship between these two entities and the attributes. Okay, this is the relationships one to many, right? Okay, a relational table basically stores a collection of related entities, and it resembles a file. Okay, but it's different with the file system, which is file system is a structural independence, but a relational table is purely logical structure. Okay, meaning that data are physically stored in the database with no concern to the user or the designer. Okay, so other reason for the relational data models rise to dominance is because it is a powerful and flexible query language. Okay, so structured query language allows the user to specify what must be done without specifying how it must be done. And SQL based relational database application involves user interface, okay, a collection of tables stored in database, which is linked using common attributes, okay, and also the SQL engine, which is executes all queries. Okay, please scan this QR code to get the tutorial files. Okay, and the code is 369. Okay, now is the fourth type of data model, which is entity relationship model, ERM. Okay, even though the relational model has improved the hierarchical and network models, but it is still has a lag in some features. So database designers prefer to use graphical tools in which entities and their relationships are depicted in a form of pictures. Okay, so in 1976, entity relationship models was introduced by Chen, and it is widely accepted and because it is adapted graphical tools for data modeling. Okay, so it is became popular because it complemented the relational data model concepts. Okay, and it's represented in an entity relationship diagram, which use graphical representations to model database component. Okay, so in ERM model, entity represented in ERD by rectangle. This one. So this example shows student entity with different types entity relationship notation, which is this one is Chen notations, and this one is Crawford notations. Okay. Okay, this is how you read the ERM model. Okay, this entity is mapped to a relational table. Entity instance is equal to row in table. Entity set is a collection of like entities equal to tables, and each entity is described by a set of attributes. And relationships in ERM is one to one, many one to many, and many to many is equal to connectivity. And name is a verb. Okay. Okay, this figure shows the different types of relationships using two entity relationship notations, which is a Chen's notation and Krauss-Foot notation. And it also shows connectivity and relationships between entities. We can try to understand these models, okay, with different notations. Okay. You can also refer to the textbooks. Okay, this is another example of entity relationship models with three different notations, okay, which is Chen's notation, Krauss-Foot notation, and UML class diagram notations. Please try to understand all the relationships between the entities and with the different notations. Okay, in summary, a data model is a relatively simpler abstraction of a complex real-world data environment, right? So basic data modeling components are entities, attributes, relationships, and constraints. Okay, hierarchical model depicts a set of one-to-many relationship between a parent and its children segment. Okay, network data model use sets to represent one-to-many relationship between record types. And relational model, which is a current database implementation standard, okay, and entity relationships model is a popular graphical tool for data modeling that complements the relational model. Okay, okay, I think that's all. Thank you.